Alright, in this video, I just want to quickly go over the checkup, if you had any questions about that. Um, so we'll just start with the first part. For the most part, Learning Target 7 went pretty good. The basic main idea here is just these two questions. And so we talked about it a little bit in class, that basically if you have an irrational number, like square root of 7, that decimal goes on forever and ever and ever and ever and ever. And there's just tons and tons of digits. Um, and so the main idea of question 1 here is if you add, sum means add, if you add something to an irrational number, if you add a rational number to it, you're going to add 3 onto the front, but then it's still just going to have tons of digits. Pardon my grammar. Tons of digits. And so that is still going to be irrational. If you add any sort of rational number to an irrational, you're still going to have this big long list of digits that goes on forever, and that's what keeps it irrational. For the second part down here, explain why the product means multiply. This was probably the biggest mistake that I saw with this one when I was looking at your checkups. Product means multiply. It's not the same as adding. So if in this case we're talking about, again, an irrational number, but now we're just going to multiply it by something. This is a little bit different because it is going to change more than just one of the digits, but you're still going to have this never-ending, never repeating, or pattern, no pattern to it, list of digits. So even if you multiply every single digit in this irrational number by a rational number, it's still going to be never ending and never repeating. And so that is what makes it stay irrational. That's the big main idea for Learning Target 7. Moving on to Learning Target 8, you really, on number 3, you really need to divide by 2 first. So I remember, if you remember, I said in class a few times, like, save the square rooting until the last possible step. And at this point, there's nothing else we can do besides square root both sides. So that's when I want to square root both sides. That just leaves me with x on the left. And square root of 36 is plus or minus 6. Okay, if you think about, again, you've got to have the plus or minus in order to be at a 4. Positive 6 times 6 is 36. Negative 6 times negative 30 times negative 6 is also 36. So that's why we get both answers. Okay. Over here on number 4, we've got a square root. We want that to be the last step, though. So add 3 before you do anything else. You get square root of x equals 8. Now from this point, there's nothing else that I can do on the left side besides square both sides. If I square a square root, I just end up with x equals 64. This is not plus or minus 64 because 8 squared only has one answer. If you take 8 times 8, you will only get 64. You will not get negative 64. Okay? So that's the difference here, is where you've got the plus or minus here because of square rooting. You do not have it over here because 8 squared is only 64. 8 squared is not negative 64. Okay? The back side of your checkup was Learning Target 9. We did a little bit of this in class. This first one, think of it as combining like terms. So it's like we're doing 3x plus 7x, which gives normally 10x. But in this case, these are square roots of 3. So this gives you 10 square root of 3. Don't combine the 3's together to make 10 square root of 6. You cannot, when you add square roots, you don't combine them under the square root sign. You just leave the 3 under the square root sign. You just leave it alone. It's like saying, how many square roots of 3 do we have? We have 3, and then we have 7 for 10 total. I'm going to skip number 6 for just a minute. On number 7, I would rewrite this whole thing under one big radical. 35 divided by 7 is just 5. And square root of 5 is irrational. Don't write down a big long decimal. This is your final answer. And that one went pretty good for the most part. Back over to number 6. Since we are multiplying, you can actually change what's under the radical. So when you multiply, that's where you can rewrite it like this, under one radical, sort of like what we did with division. This then equals square root of 56. And most people were able to get that part fine. One part that we didn't talk too much about with period 2, but we did with, sorry, I have that backwards. We didn't talk about it that much with period 7. We did with period 2, was how to simplify this. And again, this is one of those things that just brings you to a 4. So it's not like a huge concept, but it is something that'll bring you to a 4 here. To simplify this, we're going to sort of make like a factor tree. And I'm going to look at what factors does this have. And what I'm looking for is hopefully one of these factors that goes into 56 is a perfect square. So I'm going to try sort of the different perfect squares. Like if I try to divide this by 9, it's not divisible by 9. 16, it's not divisible by 16, but it is divisible by 4. So I can break this down into square root of 4 times square root of 14. And we know square root of 4 is just 2. Square root of 14 does not break down any further. So this is our most simplified answer. And again, this is what brings you up to the 4 level for this learning target. Okay. Number 8, the first thing here is just make sure you do distributive property. So that will give you, and I would definitely write out this step. Sometimes with distributive property we don't. But with these it's harder, so I would. This is what you get after you distribute. A square root of 3 times a square root of 3 is just 3. Plus square root of 3 times square root of 2 is square root of 6. And then the number out in front is just a 4. So this actually becomes our final answer. Common mistakes on this were people not simplifying this all the way to 3. Like I saw a lot of this. And that just means you just need to go one step further to get to here. I also saw a lot of trying to combine this into like 7 root 6. This is not a 3 root 6. This is just a 3. So it's not like you're saying I have 3 root 6 plus 4 root 6, so total of 7 root 6, because this is just a 3. Those were kind of some of the common mistakes. If you go through this video and you see something on your paper that I did not address in this video, please feel free to send me a question or an email with a question. Hopefully that kind of answers all your questions about the checkup. But again, if it doesn't, please feel free to email me and ask me anything that you're still wondering about or you're still confused about.